All right, welcome to The Explainer. Today we are digging into something, well, pretty radical. A new way to give AI a memory that actually sticks around, to get past the limits of what we can do today. We're talking about a blueprint for an AI that doesn't just spit back answers, but one that genuinely learns and remembers forever.
Okay, so to really get this, we have to start with this really powerful idea. We're in this new world of what some people are calling software 2.0. And what that means is programming an AI, it's not so much about writing lines of code anymore, it's really about curating the perfect data, right? The quality of the info you feed the machine, that's what shapes how it acts. But you see, that creates a brand new problem. If your data is your code, and that data is always changing, how does the program ever remember what it's supposed to have learned? That right there, that shift, it exposes this massive architectural flaw. So before we get to the solution, we've got to look at how things are done right now, the industry standard. And you're going to see why it's fundamentally broken. We're talking about a system that by its very nature has a serious case of amnesia. You've probably heard of it. It's called Retrieval Augmented Generation, or RAG for short. So here's the deal with RAG. It takes all your documents, right? And it just chops them up into these tiny little pieces. Then it does this clever thing where it turns those pieces into numbers, into what are called vectors. You can just think of them like coordinates on a giant map of meaning. So when you ask a question, it just zips around that map, finds the most relevant little fragments, and then stitches them together to give you an answer, all on the fly. But, and this is the big but, here is the critical flaw. This whole process, this on-the-fly thing, suffers from what you can only call architectural amnesia. The AI has absolutely no memory of what it just did. So here's the bottom line. RAG never truly learns. Not really. Every single time you talk to it, it's a completely blank slate. It has to reread and reprocess the information from scratch every single time, which, as you can imagine, is just incredibly inefficient, it's super expensive, and it makes it impossible for knowledge to actually build up over time. Okay, so what if, instead of this forgetful, line-by-line interpreter, what if we built a wise compiler for knowledge? Now, if you're not a coder, don't worry. An interpreter is like reading a recipe one step at a time every time you cook. A compiler is like reading the whole recipe once, memorizing it, and then just knowing how to cook the dish forever. That's the core idea behind what's called the LLM wiki. It's a system that's built from the ground up to have a permanent, growing memory. So the fundamental shift here is moving from figuring it out when you ask, that's interpretation, to figuring it out when the information first comes in. That's compilation. See the difference? Instead of scrambling to put the pieces together on the fly, the LLM wiki does all the heavy lifting up front. It reads, it understands, and it organizes the information just once. And when you look at them side by side, the trade-offs are just crystal clear. RAG is stateless, it forgets everything, and it's expensive with every single query. The LLM wiki, it's the total opposite. The knowledge is persistent, the queries are super fast, and this is a huge deal. You completely own your data. It's not locked away in some company's proprietary database. It's just a bunch of simple text files.
Okay, so how does this thing actually work? How do you build this memory? Well, it all comes down to a really disciplined, rigidly structured file system. People sometimes call it the three-folder rule. And this simple structure is what turns a basic computer directory into an AI's brain.
First up, you've got the raw directory. This is where everything new lands. Reports, your notes, meeting transcripts, you name it. And this is the intake valve. Crucially, there's a human gatekeeper here, making sure only high-quality, relevant stuff gets in. This is your first line of defense against the classic garbage in, garbage out problem. Next, there's the config directory. You can think of this as the AI's constitution. Seriously, it's a master file of strict, non-negotiable rules. This is what transforms a generic, off-the-shelf model into a disciplined, super-focused knowledge worker. It literally tells the AI exactly how to think and how to behave. And finally, we have the wiki directory. This is it. This is the output. This is the AI's actual memory. And what is it? It's a clean, organized network of interconnected Markdown files. And if you don't know, Markdown files are just simple, human-readable text files. This means instead of the AI having to dig through messy, raw documents every time, it can just instantly read knowledge that's already been perfectly synthesized and structured for it. So this whole system just runs in a constant loop with three phases. First, it ingests new data by compiling it into the wiki. Second, it answers your questions, and if it learns something new in the process, it writes that back into the wiki. And third, it's always linting, that's a coder term for cleaning up. It's always self-healing its own knowledge base, fixing errors and getting rid of contradictions. It's a living system. Okay, so let's get practical. Let's talk about the payoff versus the price. Because this approach, it has some absolutely game-changing benefits. But, it's not a free lunch. There are definitely costs involved.
I mean, look at this. The efficiency gain is just staggering. We're talking about a potential 95% reduction in costs per query. And you might ask, why? Well, it's simple. You're no longer paying the AI to do the heavy lifting of rereading and reanalyzing huge, messy documents every single time. You're just asking it to read the perfect, pre-digested summary that it already made for itself.
So the upsides here are just massive. 1, your AI's knowledge actually grows and compounds over time. 2, it's radically cheaper to run. 3, it's all just simple text files, which means you, a human, can read it, you can audit it, you can even edit it. And 4, you're not locked into one AI vendor. You can take this brain and plug it into any model you want. You literally own your AI's brain.
But like I said, there's a price. And the price you pay is complexity. This is not some simple plug-and-play solution. Nope. It takes real engineering work to build out the automation, and it requires a serious commitment to human oversight, to curating that data and making sure the quality stays high.
So, why does any of this really matter? What's the big picture here? Because this isn't just some clever new technical pattern. This is really a foundational step toward a much, much grander vision for what artificial intelligence could actually become.
Believe it or not, this idea has roots that go way back. We're talking 1945. A scientist named Vannevar Bush dreamed of a machine he called the Memex. And his vision was a device that would store, and this is the key part, connect all of a person's knowledge, creating these associative trails between different ideas.
It was a beautiful, powerful vision, and it was completely impossible for almost 80 years. Why? Because the sheer amount of human effort needed to maintain all those connections, it was just crushing. Nobody could do it. But the LLM wiki, it finally solves this core problem. It takes that infinite, tireless job of maintenance and gives it to an autonomous AI agent.
What we're looking at here is a foundational piece for building truly autonomous systems. Systems that don't just answer our questions, but that actually compound their own intelligence over time. And it leaves us with this one really big question to think about. What happens? What becomes possible when an AI never forgets?